Good morning, everybody, and welcome back to AI Blades. My name's David Willis-Owen, and I bring you cutting-edge AI security every single week. I'd like to say a massive thank you for the engagement we've had over the past few weeks. I recently set up a YouTube channel, and it's already gained over 50 subscribers and thousands of views. So thank you so much. In response to that, I've decided to make this podcast an actual video format. So feel free to head on over to YouTube and watch the whole thing. Before you click off, I'd like to invite you to stay till the very end of this show. We have an incredibly exciting topic, and I'm sure I can provide value to any AI security researchers, anyone in the technology space, or anyone just interested in this topic as a whole. We're going to be covering how Hugging Face was ethically hacked. To begin with, we'll look at what Hugging Face actually is. Then, we'll move on to considering Pickle in PyTorch. We'll move on to a case study where we'll take a deep dive into how hackers were able to compromise Hugging Face. Next, we'll assess the potential consequences and countermeasures to this attack. Finally, we will revisit Pickle and look ahead to the future. To begin with, what is Hugging Face? Hugging Face is the largest AI as a service platform, and it could be compared to GitHub for AI. It allows users to perform several actions related to AI ML online, such as uploading AI models for others to use, downloading models made public by other users, hosting and running your own models on their infrastructure, and also accessing large public datasets for the purposes of training. Hugging Face is clearly a big deal in the AI space, and it provides immense value to developers. Naturally, this also makes it a fantastic target for attackers. Next, let's look at Pickle in PyTorch. The most common framework for machine learning models in 2024 is PyTorch, and this is a library in Python. However, when PyTorch loads models, it uses a library called Pickle to perform deserialization. I have a blog post on this. You can go through, look in the description, but to cut a long story short, deserializing objects insecurely can lead to remote code execution, allowing hackers to execute commands on the target machine. While Hugging Face scans pickled files and warns users of their associated risks, it still has to support their usage because of the ubiquity of PyTorch in the AI community. Now, let's take a look at how researchers at Wiz used Pickle to compromise Hugging Face. To begin with, the Hugging Face Inference API is a tool that allows users to host and run their own models on a server. They can query it similar to a large language model, asking it commands and then getting back suitable responses. So the researchers over at Wiz cloned a GPT model, then injected code to launch a reverse shell upon loading, creating the payload. The researchers didn't specify how this was actually done. However, I used a guide I found to construct some code similar to what the researchers may have used. Put simply, you can actually inject a reverse shell into the pickled payload, and then when it runs, this will execute. I did this by hand to improve my learning, and you can see the screenshots on my blog post. However, the researchers likely used a tool called fickling. Fickling allows you to straight up inject the commands without having to rewrite all of the code, and you can rebuild these commands into the pickle file automatically, allowing you to quickly have a suitable payload. Initial access. Upon uploading their malicious file to Hugging Face and interacting it with its initial access. Upon uploading the malicious file to Hugging Face and interacting with it via the Inference API, this happened. So on the screen, I have a picture of initial access. Upon uploading the malicious file to Hugging Face and interacting with it via the inference API, the attackers were able to get a connection back to a listening machine. This shows the connection is successful and the code was insecurely deserialized and executed, giving the researchers command line access to the machine's environment. The ethical hackers decided to take it one step further. They modified their script to actually interact with the Python functions used in the inference API, and this allowed them to send shell commands and receive the outputs of these commands directly through the API's interface instead of requiring a reverse shell. I have a very cool screenshot for those of you watching in the video. The researchers actually decided to put the ID command into a prompt and they got back the actual outputs from the underlying Linux machine. So very, very cool exploit to see. Okay, now Amazon EKS privilege escalation. You can feel free to skip this part if you care more about the impacts of the attack, but this is very interesting and it should further your technical understanding. Next, the team executed commands to find the type of environment they had access to, and they realized the model was running inside a pod in a Kubernetes cluster hosted on Amazon Elastic Kubernetes service. You can read more about Kubernetes in the link in the blog post, but put simply, a pod is an environment which is used to run containers. Containers are small, executable, standalone code packages and are used in many modern architectures for applications. Wiz were able to escalate their privileges in this environment to obtain the role of a node, which is a Kubernetes machine with access to several pods, and this allowed them to perform further unauthorized actions. Their explanation in the blog post again was very vague, so I followed the steps in a lab to demonstrate how it works. To begin with, you can query the instance metadata service. And in this case, the node was misconfigured to have this running. This allows the user to begin with, you can query the IAM role name. The node was misconfigured with its instance metadata service, or IMDS, running. By using curl, we can retrieve the role associated with the instance. And in this case, the output of that command was EKS challenge cluster node group node instance role. Next up, you can actually use this to query the identity access management role credentials. Now we know the role name. Next up, you can actually use this to query the IAM role credentials. Now we know the role name, we can retrieve its associated credentials, again due to this IAM. Next up, we can actually query the IAM role credentials. Now we know the role name, we can retrieve its associated credentials, again due to the IMDS misconfiguration. Doing this actually gives us an access key ID, a secret access key, and other information that we can use to further escalate our privileges. The next command is to configure the AWS command line interface by setting the relevant fields with the credentials we obtained. So AWS configure set AWS access key ID, and then two other commands for the other parts of the authentication. Finally, we can use this to retrieve the EKS cluster token. This command uses the configured AWS CLI to obtain a token for the entire EKS cluster, and that command is AWS EKS get token -- cluster name Wiz EKS challenge, which is the cluster in this lab. Using that cluster token, the researchers were able to view the secrets associated with their pod using kubectl get secrets. This allowed them to perform lateral movements within the EKS cluster. Now, let's look at the potential consequences. The secrets obtained could have enabled cross-tenant access, so viewing other people's information, and this would compromise the confidentiality aspect of customer data. This may have also allowed the researchers to compromise the integrity and availability of other pods in the cluster with update and delete commands relevant to Kubernetes. This whole attack chain is unique, insightful, and frightening. By chaining remote code execution with AWS privilege escalation, an attacker could theoretically read all the data you submit to your model. Let's look at the countermeasures. Hugging Face released their own blog post in response to Wiz's blog post, claiming they have resolved all the issues uncovered. They have also begun adopting Wiz's security technology to thwart future threats. Hugging Face did not disclose exactly how they fixed the misconfigurations, but we can take a fairly good guess. To begin with, to prevent privilege escalation, the developers likely enabled something called IMDS v2 with hop limits. Basically, this prevents pods from accessing the instance metadata and obtaining the node role in the cluster, which then allowed the privilege escalation. So we've got that covered, but there is an elephant in the room, and that is Pickle. Preventing RCE via Pickle is much more complex. Hugging Face has decided to continue supporting Pickle, given its still widespread adoption in the community, while mitigating the risks associated with it, using the following measures. To begin with, developing automated Pickle scanning tools, and also segmenting and enhancing security of the areas in which Pickle models are used. Let's revisit Pickle. Based on their blog post, it is clear that Hugging Face wants people to move away from using it. Here's what they had to say about Pickle. We intend to continue to be the leader in protecting and securing the AI community. Part of this will be monitoring and addressing risks related to Pickle files. Sunsetting support of Pickle is also not out of the question either. However, we do our best to balance the impact on the community as part of a decision like this. Hugging Face has collaborated heavily on a model called Safe Tensors, and this is a secure alternative to using Pickle files. They are also actively releasing materials, educating users on the risks of AI ML models. These really are some commendable efforts which will help in making Pickle a less effective attack vector for threat actors. Final thoughts. Using a combination of Pickle remote code execution and a misconfigured cloud environment, Wiz researchers were able to hack Hugging Face severely. To improve AI security, I want all of us to stop using the Pickle library if we can. So begin proactively replacing your Pickle files with safe tensors and keep opening issues upstream about security to your favorite libraries to push secure defaults as much as possible upstream. In my opinion, this is just the tip of the iceberg. Several platforms are likely vulnerable in some capacity to similar attacks where they do support Pickle. As the AI ML community continues to push new features at a breakneck pace, more and more vulnerabilities will be introduced, giving way to exploits with devastating real-world impacts in the future. Okay, and that's a wrap. Thank you so much, everybody, for listening. I hope you enjoyed listening to it as much as I enjoyed filming and recording. Next week, we have a very exciting topic looking more in depth technically at some AI/ML security risks. But in the meantime, feel free to check out my other stuff and please subscribe, share this, and like it if you can. Okay, thank you so much for listening. Have an incredible rest of the day, and I will see you in the next show.